In this next section, 2.3, we're going to take a look at linear applications, essentially linear word problems. So for our linear application problems, just some general guidelines to follow as we're trying to figure this out. All right, there is no set series of steps that's going to work every single time. There's not the same formula that's going to work for every single problem. Okay, so when we're dealing with an application problem, we want to identify what the question is, what are we being asked to find. Jot down some notes. Sometimes putting it on paper, being able to see some things written out helps to trigger something in your brain and make sense of the problem in front of you. Write set up equations. Okay, once you figure out what equation may or may not work, write it down and see if it can get you somewhere. Okay, once you have one, an equation written down where you have all the variables, set essentially aside from one or maybe two if you have a system of equations, one that is solvable essentially, go ahead and try and solve that equation. If you have something that's not solvable, then you need to go back at your setup and try and look. There's something that you're probably missing, whether it's the wrong equation, whether there's another piece of information hidden somewhere that you didn't see, but there's something that's not quite there. And last but not least, check your solutions. Especially with these, use common sense. Make sure that the answers you get are feasible. Make sure that they make sense. Make sure they're reasonable for the situation. If you're doing a problem that, I don't know, involves buying cookies and milk, for example, or something like that, you're going to the grocery store, if you get an answer where a gallon of milk comes out to be $45, you should probably go back and take a look because it doesn't make sense in context. Okay? Make sure that you did everything correctly because there's probably a mistake in there. Maybe you moved a decimal or had the decimal placed the wrong spot. Okay, so let's go through, let's do a couple here, and we will do a few more face-to-face in class tomorrow. So just a couple of real quick formulas before we get to that that you guys should know or refresh yourself on, specifically ones that are going to pop up. Perimeter really of any object, whether it's a rectangle, square, triangle, so on and so forth. Right? Here I have the perimeter of a rectangle formula, P equals 2L plus 2W. Right? Simple interest, I equals PRT, where P is the principal amount or the amount invested. R is the interest rate as a decimal. All right, so 6% interest rate must be converted to 0.06. And time is always in years because our interest rate is an annual interest rate. All right. Additionally, you should be familiar with the basic geometry formulas. Area, volume, for your basic shapes. Squares, rectangles, triangles, circles, so on and so forth, trapezoids. Okay. Am I going to expect that you know the surface area formula for a triangular pyramid? Absolutely not. Okay, I'm talking about the basic, what you should know, what you're going to learn in your regular, straightforward high school geometry class. All right, and again, I'm looking at volumes and areas of your regular or basic shapes. If you need something for another formula, it'll probably be given to you or you'll be able to look it up. So let's actually do a couple of problems here. So let's say I have the width of a rectangle is 8 inches shorter than its length. If the perimeter of the rectangle is 32 inches, we want to find the area. First things first, I'm a visual person, and a lot of people also are, whether they realize it or not. So my biggest hint a lot of times is draw a picture. Okay, so I've got a length, I've got a width, and my problem tells me that the width is 8 inches shorter than the length. So let me actually adjust my photo here so that it is the right orientation. So let's say we've got a length, okay, and my width is 8 inches shorter than the length, so the width would have to be 8, or L minus 8. Okay, I know that the perimeter is 32 inches. Okay, so if you remember, perimeter equals 2L plus 2W, right? And my width equaled L minus 8. So I'm going to go ahead, I'm going to make some substitutions here, right? I know my perimeter is 32. And I got 2L plus 2 times L minus 8. So when I go and simplify here, we're going to have 32 equals 2L plus 2L minus 16. Or I'm going to have 48 equals 4L, or L equals 12. I'm not done. I've solved for L, but I haven't actually found the area. Remember I said to identify, circle, box, highlight, underline, whatever you got to do, make a note of what it is you're solving for, so you don't get to this point and say, oh, throw a box around it, I have an answer. You're not there yet. Okay, I need to know the area. Area is length times width. So I'm going to take this length of 12 and I'm going to substitute it in. So we're going to have 12 times 12 minus 8, right? Or 12 times 4, and in this case it just happened to work out to a number that we saw somewhere earlier in that 48. Doesn't always work that way, right? One other thing, if I throw a box around this, I'm going to take off a point. The reason being, in this problem, we're dealing with inches, and I'm dealing with an area, so this should be square inches. If there are units applicable to the problem, please make sure that you are using those units at the very least in your final answer. I don't expect, it's not a science class, I don't expect you to carry units the whole way through a problem. However, when you get to the end of a problem, I do want to see those final units expressed. The second one I have is find the perimeter of a triangle. If one side is 12 inches, another side is 2 inches more than 1/2 the perimeter, and a third side is 1/4 of the perimeter. So let me just draw a triangle here. Okay, so let's see if we can make it at least semi-irregular. So perimeter of a triangle is essentially going to be side 1 plus side 2 plus side 3. Okay, I want to find the perimeter of a triangle, knowing that one side is 12 inches. Okay, so let's just go with this one being 12 inches. Another side is 2 inches more than 1/2 of the perimeter. All right, so we're going to have 1/2 P plus 2, and the other side is 1/4 of the perimeter. So we're going to go with 1/4 P. Right, so what I can have here, and P represents the total perimeter of this particular triangle, right? I have expressions for each of my 3 sides, and 2 of my 3 sides use the variable P that I already have here. I don't know what that variable is going to equal yet, but we can then solve for it. So let's substitute. So we're going to P equals 12 plus 1/2 P plus 2 plus 1/4 P. So if I combine like terms, we're going to have P equals 3/4 P plus 14. And if I subtract 3/4, I end up with 1/4 P, or P over 4, equals 14. If I were to multiply both sides of my equation by 4, we're going to get that P equals 56. So my perimeter, right, again, what are we identifying that we're supposed to find? Find the perimeter. My perimeter here is going to be 56 inches, right, again, with appropriate units. The next one that I have here is you win $24,000, lucky you, and you decide to invest the money in 2 different investments, one paying 18% and the other paying 12%. A year later, you collectively have $27,480. How much money did you originally invest in each account? So here I've got my simple interest formula, I equals PRT. Okay. One thing here, my interest total is going to be my interest from account number 1 plus my interest from account number 2. Okay. If I had a principal investment of $24,000, and after interest I have $27,480, okay? My principal and interest minus my principal will give me the interest amount, okay? So here, I think you guys can see that my interest total that I've earned in that 1 year is $3,480. Okay. I do know time for both is 1 year. And I know my interest rate, number one, is 18% or 0.18. And my interest rate for my second account is 12% or 0.12. So when I do some substituting here, right, really I have P R1T plus P2 R2T. Okay, so the problem I run into is how do I express the difference from the principal 1 to principal 2? So if of my $24,000, I put X dollars into my first account, I have 24,000 minus X dollars left to invest into my second account. So let me go ahead and substitute here. We're going to have $3,480 equals, we'll use X times 0.18 times an amount of 1 year plus 24,000 minus X times 0.12, again, times 1 year. So I want to distribute and simplify. So I'm going to have 3480 equals 0.18x plus 2,880 minus 0.12x. So I'll combine like terms. I'm going to subtract over the 2880, so 3480 minus 2880, we're going to have 600 equals 0.06x. I want to divide both sides by 0.06, and when I do that, 600 divided by 0.06 is going to give me $10,000. Now X, if I come back up here, X is the amount that I invested into account number 1. 24,000 minus X is going to represent the amount that I invested into account number 2. So obviously then, this is principal for account 1 is $10,000, and that then leaves me with a principal amount for account 2 of $14,000. And again, I go back and check how much did you originally invest in each account. I've now answered that. We're good to go. The last one that I want to do here for the notes today is a mixture problem. All right, so let's suppose for an experiment it requires 100 milliliters of a solution that is 11% hydrochloric acid. The storeroom has only solutions available that are 5% hydrochloric acid and 11% hydrochloric acid. How many milliliters of each available solution should you mix to get exactly 100 milliliters of an 11% solution? So let me jot out something for our mixture problems. Okay? When we're dealing with mixture problems, what we're really talking about is how much pure substance do we have from each individual component of that mixture. Okay, so we're going to be dealing with, a percent concentration and an amount or a volume. Okay, so we're going to have an amount total times a concentration total equal to, and usually it could be a sum. There are other ways that this could be set up, or maybe I'm taking some out and putting another amount in. Here I'm just simply mixing the two together. So I could have amount 1 times percent 1, or the concentration number 1, plus amount 2 times a percent concentration for the second. Again, this is a basic setup. There are some other ways you can do this and other types of problems that can be entertained, if you will. Okay, so here my total amount must equal 100 milliliters of 11% hydrochloric acid. So I'm going to have 100 times 0.11 equal to my solution number one. All right, I've got a 5% solution and a 15% solution. So let's do X milliliters of my 5% solution plus, and similar to how we figured out how much is left over in the interest problem above, I can do the same thing here. I need 100 milliliters total. If I use X milliliters for the first, I now have 100 minus X milliliters remaining for my second 15% solution. So at this point now I'm going to multiply, and I'm going to try to combine some like terms here. So we're going to get 11 equals 0.05x plus 15 minus 0.15x. If I subtract 15 from both sides, I get negative 4 equals negative 0.10x. Negative 0.10 is the same thing as negative 1/10. So if I multiply both sides by negative 10, I'm going to get that x equals 40 milliliters. So I'm asked to find how many milliliters of each available solution I should use. So I here have solution of the 0.05 or the 5% concentration, and if I need 100 milliliters total, I then need, of my 15% solution, I need 60 milliliters to come up with that 100 milliliter total. I give some of these problems a shot. The hardest part in a lot of them is figuring out how to set them up. Once you have them set up, usually the math goes pretty easily. Okay, sometimes you're gonna have to write some things down. You're gonna have to remember a couple of different setups or formulas. I would write down somewhere in your notes that you can find this percent mixture setup or formula. Okay, it's going to pop up later throughout this course, and also, you know, depending if you're in chem or physics, you may see something like this there as well. Okay, have a good night, and I'll see you guys tomorrow.